everyone, welcome to the session on object oriented programming. Let me introduce myself first. My name is Pooja and I'm working as an assistant professor in the Department of Information and Technology, SNS College of Technology. So, whether you're a beginner in coding or someone brushing up on the concepts, this video will guide you step by step into the fundamentals of OOPS. We'll cover what OOPS is, why it's used so widely, and the core concepts that make it so powerful. By the end, you'll clearly understand how OOPS helps us write cleaner, more efficient, and scalable programs. So, first, let us dive into what OOPS is actually. So let's start with the basics. OOPS or object oriented programming is a way of writing code that revolves around the objects. These objects combine the data, which are the variables, and behavior, which are the functions or methods that work on the data. Think about a car. A car has data like color, brand, speed, fuel capacity. So it also has behaviors like start, stop, accelerate, or brake. In OOPS, we can represent a car as an object that bundles both its properties and objects or actions. The advantage of this approach is that it helps us to reuse the codes, organize project better, and softwares easier to scale and maintain. So let's dive into the key concepts of OOPS. OOPS has four main building concepts or four main building blocks. Often these are called as its pillars. The first is the objects. These are the actual entities created in a program, like an object, a car, or a object, a student. Each object has its own data and a behavior. Second, classes. A class is like a blueprint. For example, a car, describes what a car should look like and how it should behave, but only when the creator of an object from this class says a red BMW. Does it come alive? Third, encapsulation. This means building or bundling data and methods together inside a class so they are protected from the outside interferences. This is like the dashboard of a car. You don't see actually the internal wirings, but you see the interface you are allowed to see. Inheritance allows us to create new classes based on the existing ones. For example, suppose we have a base class called as the vehicle. It has properties like number of wheels and methods like start and stop. Now, if we create a subclass car, it automatically inherits those features. We don't need to rewrite the code. We can even extend it by adding multiple or unique properties like air conditioning or music systems. It makes us the code reusable and saves a lot of development times. And then now when it comes to the types of inheritance, there are different types of inheritance in programming. Those are single inheritance, multiple inheritance, and hierarchical inheritance. For example, in single inheritance where one class inherits from the other, like the car inheriting from the vehicle. Multiple inheritance where one class can inherit from two or more classes. For example, a class flying car could inherit features from both car and aeroplane. Hierarchical inheritance, where multiple classes inherit from one base class. For example, car, bike, truck, and all that can inherit from the basic class vehicle. Each of these help to model real world relationships in a code. And then, when it comes to method overriding, this happens when a child class redefines a method that already exists in the parent class. For example, the base class vehicle may have a method called as the fuel typing. Like a car subclass could override it to return petrol or diesel, while a bike might return only petrol. This allows more specific behaviors for each subclass without changing the original base class. Now let's understand what is polymorphism. The word itself means many forms. It allows one function name or operator to behave differently depending on the object that calls it. For example, let's say we have a method make sound. If it's used by a dog object, it may bark, while if it's used by a cat object, it may meow. The same inheritance or the same interface, but different behaviors. This is extremely powerful when you're working with large systems because you can write flexible and dynamic codes. Method overriding. Closely related is method overriding or overloading. This method overloading, it happens when multiple methods in the same class have the same name but different parameters. Let's take an example. We can have one method add that takes two integers and another add that takes three integers. Both share the same name, but the program can distinguish them based on the input. This makes the code cleaner and more intuitive. Interference implementation. Interfaces are like contracts in programs. They define a set of methods that a class must implement, but they don't provide the actual code. It's like a rule book where you agree to follow the interfaces. Your class has to provide the details for those rules. This ensures the consistency across different classes. And now let's understand what is abstraction. To implement abstraction, we often use abstract classes. An abstract class is like a half-complete blueprint. It can define some methods, but it leaves other abstract, meaning subclasses must provide their own implementation. This ensures that certain rules are followed while still allowing customization. Let's take an example for an abstract class shape. It could define a method calculate area, but not specify how. A subclass circle or rectangle would then provide its own way of calculating the area. Real world modeling. One of the biggest strengths of OOPS is its ability to model the real world entities. Let's say we want to model a library system. We can create a class book with attributes like title, author, and price, and methods like issue book and return book. Similarly, we can create a class member with its own data and behavior. By connecting these objects, we can represent a real world system in code in a way that's intuitive and easy to expand later. So let's dive into the advantages of OOPS. Some of those advantages are code reusability. Instead of rewriting the code, we inherit and reuse it. Maintainability. Since classes are modular, it's easier to debug or update without affecting the whole program. Collaborations. In a team project, different developers can work on different classes at the same time. Scalability. As project grows, OOPS helps keep things organized and manageable. So, in conclusion, object oriented programming is much more than just a style of coding. It's a structured way of thinking about the problems by modeling them as real world entities. The four core principles encapsulation, inheritance, polymorphism, and abstraction are the building blocks of this approach. Once you master these, you'll find it much easier to design and develop the complex applications. Thank you for staying with me till the end of this session. If you found this video useful, don't forget to hit the like button, share it with your friends, and subscribe for more educational content.